So we have a question here that's an example of what's called a constant motion problem. Right? And what really tips me off to how we're going to solve this is when I read it, I see it's a question that involves times, it's a question that involves distances, and it's a question that involves rates or speeds. And I'm always happy when I see those things in a question because we have a formula that relates those three variables: distance equals rate times time. And that's the formula that we're going to use to answer this. Now, the way I like to approach a lot of these kinds of problems is to organize the information into a table. Okay, so my table is going to have four columns. The first one is just for this scenario. That's going to be with the wind. It's one of my situations, and against the wind. And the other three columns come from the formula: rate, time, and distance. And the way I always set these up is in such a way that I can multiply across the rows. Right? Rate times time equals distance. Okay, so now let's go to the question, and just kind of read through it, right? And pick out the individual numbers and pieces and put them into our table here. So we have a plane that's flying between two cities. When it flies against the wind, it takes 2.75 hours. All right, so let's put that in the table. When it flies with the wind, it only takes 2.5. If the distance between the cities is 1,100 miles, so that's the same for both trips, right? So I'm going to put 1,100 in both distance rows. How fast was the plane traveling, and what was the wind speed? Okay, so I'm being asked for two things, right? The two speeds. So that makes me think I'm going to need two variables, right? So I'm going to let W be the speed of the wind, and I'm going to let P be the speed of the plane. All right, so what does that give me for the rates? Well, when the plane is going with the wind, that means the wind is behind the plane. It's pushing the plane forward and speeding it up. So the total speed, the total rate in that scenario is going to be P plus W, the speed of the engines plus the speed of the wind. Going against the wind is the other way around. Now the wind is in the face of the plane, and it's slowing it down. So in this case, the net rate is going to be P minus W. Awesome, we filled in the table, and that's enough to give me some equations. If I multiply across the first row, I get 2.5 times P plus W equals 1,100. And if I multiply across the second row, the last row, I get 2.75 times P minus W equals 1,100. Okay, great, two equations. In two variables, and that's fine. We have some tools for solving this kind of situation. So first, I'm obviously out of room. So I've just copied our equations over, right? So we can kind of start with a fresh page here. So I want to solve this system of equations. And the first thing we need to do is eliminate the parentheses. Now, we've seen this kind of situation before, and what we would usually do is use the distributive property, right? Distribute 2.5 into the first parentheses, 2.75 into the second, and that would work. You could absolutely do it that way. But I'm looking at these equations, and I got that P plus W and that P minus W. That is a textbook setup for the elimination method. If I add those two equations together, the W's would go away, and all I'd be left with is P's, and that would be great. But I can't, because the 2.5 and the 2.75 out in front are getting in the way. One way or another, I got to do something with them first. So what I'm going to do is I'm going to divide by them. Right? If I take the first equation, divide both sides by 2.5, it becomes P plus W equals 1,100 divided by 2.5, which is 440. All right, now do it with the other one. Divide both sides by 2.75, and it becomes P minus W equals 400. That's what I needed to see. Now I'm going to take that second equation, and I'm just going to copy it over here under the first one, and I'm going to add them together. Right, when I do that, I get what P plus P is 2P. W minus W is 0. That part goes away. 440 plus 400 is 880. Now we're down to one variable. Divide both sides by 2, and we get the speed of the plane. Right, 440. Okay, now I still need the wind speed, right? So I'm going to take that 440, and I'm going to substitute it back into the other equation. That's going to make it 440 minus W equals 400. And to solve it, well, we'll subtract 440 from both sides, divide by -1 so the W becomes positive, and we get W equals 40. And that was the missing piece. All right, so now we're not done though, right? Remember, you got to fully state the answer when you get done with your calculation. So my final answer would be the plane is going 440 miles per hour and the wind is going 40 miles per hour. So if you like this, please don't forget to click on the like button down below. And if you'd like to see more like it, there's a subscribe button down there as well.